Live. I just had a good idea to kind of show off the process where I actually do one of these photogrammetry scans. Today is Sunday, and there's a pretty interesting little parking lot nearby at the FedEx distribution center. And I know they're closed on Sundays. It's an empty parking lot. They have some attractive walls that I think would be nice for like a photo map for Assetto Corsa. So I thought I would maybe turn it into a tutorial at some point. Hope you enjoy. Oh, you love the track. Oh, Daniel, hey, yes, thank you. I appreciate that. So just going to give you a little bit of insight into how I do one of these scans here. Today we're just heading over to a little parking lot, so this is not going to be like a full road, but it is going to show off the whole process and how I mount the camera and everything. Yeah, you know, I'd love to see more people taking this kind of approach for their own mods for Assetto Corsa, whether it be for a photo map or for an actual driving map. This little block that I'm on here, I might do as like a small circuit one day because it just goes in a loop as like a big square. This street that I'm on right now, I actually did scan at one point to turn into like a little drag strip, so I got to get that one finished up. But the most important thing when you're doing these photogrammetry scans outdoors is you want weather to be like it is right now, where it's very cloudy and overcast, but it's not rainy. You don't want wet, reflective roads. You don't want anything that's going to necessarily create reflections. Reflections are your biggest enemy. And as I say that, I'm pulling up to this parking lot, and there's actually a couple kind of wet spots here. But it's okay. Honestly, for what this is going to be, which is just a simple little photo map, it's not going to ruin things. I'll maybe try to patch over it or do something a little bit differently. But yeah, here we are in the parking lot, and I'm just going to shut the car off, so I don't know if something's going to change here with the sound or the Bluetooth or what have you. But I'll try to point the camera at the back seat. You can see how I set up the camera and everything. Try to walk you through some of the settings that I use and why. And basically, let me just get out here and give you a quick little tour of the area we're going to scan. So this here is the parking lot. There's a cool apartment building with like a mural on that side. You know, just FedEx and palm trees. I really like this brick wall in the background. I think that's going to be good for photos. And yeah, you know, just wanted to kind of do something a little more educational, a little more illustrative of my process. And yeah, just constantly create new content for you guys to enjoy. So if I end up going a little quiet for a minute, it just means that I'm working or thinking. But yeah, I'll be here. I'll keep it live through the whole scan. And I assume this will just live on my Instagram after, or I'll find some way to save it and share it. But yeah, so just to kind of give you a quick introduction, this is Link. This is my boy here. My other car is Zelda. So, you know, there's a theme going. And what I do is I basically just mount the tripod in the back seat here, and then I film out the back window. This is actually not probably like the best way of doing it. What I'd really like to do is like get a roof rack and like mount the camera kind of off the back somewhere and point straight down at the road. But this is, you know, this is what I got going so far. And Tyler, yes, I make mods for Assetto Corsa. I'm taking a fully photogrammetry approach to my mods. So the first release that I have out right now is called Alpine Meadows. You can go find it on my patreon.com/realsimroads. And that's about a 3-mile mountain road up near Lake Tahoe. And it's a real scan of the actual road. And yeah, so the process that I use to make that road is pretty much the same as I'm using right now. And yeah, that's why I wanted to show it off here. So I'm just going to put this down for a minute while I kind of set things up. Try not to ruin my upholstery in the process. Might be too late for that. So what's cool about this process is that you can make something pretty quickly compared to doing it by hand, right? So if I do this scan right now today on a Sunday, in theory, I should be able to have it uploaded by Monday or Tuesday at the latest. So that's one big advantage of doing photogrammetry scans, is it just saves you a lot of time over 3D modeling by hand especially because the textures and the meshes are all created at the same time. So you end up with all the assets that you need right off the bat, and then you just kind of actually reduce the sort of the quality or the amount of data and put it into the game engine. Yeah. So now you can see we have the tripod mounted, pointing down at the ground. I'll probably adjust the tilt a little bit here. I think that's a bit extreme for what I'm trying to do. And the next step is going to be to set up the camera with the widest lens that I have, which is a 16 millimeter. Now, I try to use autofocus when I can, but these lenses are adapted from Sony to Nikon. So the 16 millimeter is not going to be able to do autofocus, but that's okay, because when you're doing photogrammetry, you really want to use a very small aperture, right, which gives you a very wide depth of field. You want as much of the scene to be in focus as possible without sort of underexposing your scene. So with that in mind, I'm going to switch from the Nikon 50 here over to my Sony. And, you know, the nice thing is, like, you could use whatever camera, if you want to do this process yourself, you could use whatever camera you already have. You could use an older DSLR and take photos. You could use your phone camera and take a high-res video, 4K minimum, or take photos with, I used to use an app called Skyflow for iPhone. It was like a time-lapse app that would take DNG images with GPS information baked in, all that jazz. And that was a good way for me to learn and start experimenting before I ended up investing in some nicer camera equipment. For me, it worked out because I do video for a living, so I needed a better camera anyway, but it kind of pulls double duty here as my main photogrammetry tool. So first, let me find a memory card that is not completely full, and then we'll load it up and get going. And if you have any questions about this process while you're watching, I see we got a couple people who joined. It's awesome. Hello. Feel free to just write a comment, and I'll answer whenever possible. And like I mentioned, I'm going to do my best to try to preserve this and maybe cut it up and do a more straightforward tutorial in the future. So yeah, be on the lookout for that as well. So one of the things with photogrammetry is you really want to freeze the action. You want to have as little noise in the image as possible. So you basically need to use a really small aperture, high shutter speed, low ISO, and also film under kind of darker, cloudier conditions. So it's really not like the ideal scenario, unfortunately. You usually want either brighter light or better conditions, but we're going to have to work with what we got today. I need to take a second to try to find my tripod plate for this camera. So I'm just going to put the camera down here for a second, and then I'm going to dig around. So bear with me. And the weird thing is that I know it was here in this cup holder. Oh, found it. Okay. So when it comes to doing this type of scanning, everybody seems to have left. Okay, so Daniel asked the question, how large are my typical renders? So the actual render, the final product in terms of polygons, generally depends on the quality settings that I use for the render, but it can be anywhere from 100 million to close to 1 billion polygons. So for instance, Alpine Meadows, the original scan before I reduced it for Assetto Corsa was around 800 million polygons, and that was on the low quality setting. So that's way too much for a game engine like Assetto. But the actual data set that I captured, so the photos themselves, well, actually I shot video. So the raw video for that project was around probably 500 gigabytes. But then once you extract it into individual frames, that project was about 7 terabytes of photos, just under 30,000 35 megapixel photos. I'm going to do raw shooting today as well. I'm going to do 20 frames per second stills, because the advantage of shooting stills is that the GPS information is baked into the EXIF data for each photo. So that gives the software a better starting point as far as estimating which cameras probably overlap. It can also just help with the overall orientation and sort of geographical accuracy of the road itself. Yeah, my computer is pretty insane. I'll show that when I get back as like maybe a part 2. But yeah, today it's probably going to be somewhere on the order of 5 to 10,000 photos. Depends on how quickly I shoot this. Depends on whether I can get it all in one pass, or if I have to do 2 and like adjust the camera in between. But yeah, well, I'll update you on that once we get going here. So let me finish setting up the camera a little bit, and then I'll check back in. Oh, and here's another important tip if you're going to try to do this stuff. It helps to use a light meter. Again, I'm a cinematographer, so I kind of just had one of these lying around. But it's probably better than just trying to expose with like the in-camera metering, because what I've noticed, one of the problems I've run into is I tried to use auto exposure to try to make sure that it would stay even throughout the whole scan. But then sometimes I would end up in areas where more of the sky is visible in the frame, which then kind of auto exposure over corrects for that. So going forward, I'm going to try to do only manual exposure for consistency. Today, it's very evenly overcast, and that's going to be the best case scenario for capturing this type of stuff. And it's also not too dark. So I think we got out here at a good time before it's too late. And I'm going to talk a little bit less and scan a little bit more, so that way I'm not wasting too much of the light here. All right, so at an ISO 800, which is the second native ISO for this camera, we're reading f11, which is what I'll set my aperture to, and 1/300th of a second for our shutter speed. So I'll do one scan, I'll check the footage and see if that works, if it's sharp enough, and then I'll see if I need to do more. Now, one problem I am going to have with this scan is that the building itself has dark glass windows, and reflections are the enemy of photogrammetry. You can do a little more research, but in essence, photogrammetry works by calculating structure from motion. It uses parallax, and when you have a reflective surface, to your eye, to the camera, it looks like the reflections are moving at a different speed than the surface they're reflecting off of. So essentially, it tries to reconstruct what it thinks it sees deep in the reflection, and the windows themselves get completely messed up. So I'll probably have to fix that by hand or find some other way to correct for that. But for now, I'm not going to worry about it. I'm just going to move forward with the scan. So we're setting the camera to ISO 800. I'm actually a little worried about that shutter speed being too low. So if I stop down to, or open up actually, to, why won't you go to an 8? Well, anyway, if I open up to an 8 from an 11, then that gives me closer to 1 1/1000th of a second shutter speed. So that's what I'm going to go with, 1/1000th at an f8 ISO 800. And I also have a polarizer on the lens to try to eliminate some of those reflections. And that's also going to reduce some of the light getting through to the camera. So the scene might be a little bit dark, but that's okay. I'd rather have it be a little bit dark than a little bit bright. But really, it's not such a big deal as long as nothing is clipped, as long as nothing is overexposed or underexposed. All right, so that's mounted. Actually, one thing I almost forgot, because I've been doing videos so much lately, is I need to attach a shutter release cable so that way I can lock the shutter down in the high speed mode and get the full 20 frames per second of recording all the time. So let's go and format this memory card. All right, so now we can shoot about 2,800 raw photos on this memory card. So hopefully we don't fill it up doing our first scan. I think we'll be okay. And yeah, we'll just get going. Now I do want to reiterate, I have a very fancy camera for doing this because I'm trying to do this as fast as possible with as excellent quality as possible. I want it to be the best available because I'm a little crazy like that. But you're more than welcome to do the same exact procedure using a drone, like a DJI Mavic, or using your iPhone or an older DSLR. You don't need the greatest equipment in the world. You just need to know what the limitations of your equipment are. And in general, if you have less resolution, then you're just going to want to make sure that your photos are sharper, and there's a lot of detail for the software to latch onto. Now I'm actually starting to get some direct sunlight, which is going to be a bit of a problem if it creates shadows. So I want to hurry up here. I might talk a little bit less. Now let's just make sure this is all working right. All right, so we are firing on all cylinders here. Now I mount my camera vertically when I'm doing this because I'm driving along. So, the horizontal movement is going to get captured in subsequent photos, but I want as much vertical resolution as possible for each capture so I don't have to do too many passes. I'll set the focus manually, double check and make sure that my picture looks good. And I'm actually going to tilt up a little bit here because I'm going to do so many laps that I'll probably get the parking lot anyway. I just want to make sure I get as much of the building as possible in this first scan. Now, I probably should have parked pointing at the apartment building behind me to make it easier, but too late for that. Now, I don't have a fancy mechanism for doing this. I just hook up the shutter release cable and I lock it once I start driving. So now we're going to start the scan. Now, I want to make sure that my polarizer is turned correctly. So now inside I can see the screen a little bit better. I'm just gonna give it a twist, see if things get better or worse. So now more reflections on the ground, now less reflections on the ground. So that's what I'm gonna go with. So we'll do a couple loops around here and try to get everything. If I were better prepared, I'd have a little monitor up here in front so I could really see what I'm scanning. But thank you. Yes, I appreciate the comment, Daniel. My goal is to really, kind of take an approach that nobody's taking, both in sim racing and in photogrammetry, because a lot of these location scans are done by drone, which works for, surveying, it works for construction, planning, that sort of thing. But when it comes to actually doing quality content for video games and sim racing especially, it's really important to actually have as really close up detail, right? So if you're shooting from a drone, but then you're driving on it in first person, the details don't really look that great. They it looks like it was filmed from far away, which is not comfortable. It just doesn't feel right. So that's why I've been taking this kind of close-up DSLR scanning approach, is because I want you to feel like you're really there in real life. I really want that level of detail. I want that, extreme close-up detail. And what's interesting is that Assetto Corsa really cannot support as much detail as these scans can produce. So that's why I'm really, really, really excited for the future of sim racing, the new games that are coming out using the Unreal Engine 5, because they'll be able to support this level of detail natively. And just the actual experience of driving in these simulators is going to be unmatched. So I've already got my whole scan. I pretty much am just doing a second lap here to kind of make sure that I didn't miss anything. And then I'm just going to go right back to where I started. And then I'm going to check it, see if it looks like anything's missing. And if so, I'll maybe do a second pass with the camera aimed more at the ground. But yeah, you can see in just that, 2 minutes or whatever that I was driving around, I've now scanned this entire parking lot, the buildings around it. And in, just a few hours of processing, I'll be able to turn this into a high quality photo map that you can use to take pictures or make little videos in Assetto Corsa. And that's the process. So I'm gonna check back here and I'll let you know how it went. Great. So it looks like I absolutely got all of the detail that I needed. I captured the entire parking lot, the buildings all around it, all in that one scan. So that's probably going to be all that I use for reconstruction on this one. Oh, I got some questions here. What's the most budget DIY someone can get to drive in their car and take pictures of, let's say, a local track? So I assume by most budget DIY, you're looking for kind of the lowest cost approach to doing this. So what I would recommend is, if you have complete unrestricted access to the track and you have permission and you can spend, considerable amount of time doing it, what it comes down to is that triangle you may have heard of. It's good, fast, cheap, right? Pick two. You can only have two. So if you're trying to do it good and you're trying to do it cheap, you just need to spend more time doing it. So the camera that you choose is almost inconsequential, but the amount of time that you spend scanning is going to matter more. So if you have a recent iPhone, like an iPhone 13, 14 with a higher resolution camera, I would recommend using that. And I would recommend using an app. The one that I recommend is called Skyflow. This will allow you to take a time lapse. Basically, you record 5 frames per second automatically, but it's going to take still images, and the GPS information is going to be recorded in each image. And you can even choose to do DNG raw images. JPEG might be enough. DNG is just going to give you a little more data to work with. when you're filming with this type of setup, you could use a similar arrangement to what I'm using, where I'm filming essentially out of the side of my vehicle. But on a track, depending on how wide it is, that may not be enough. So what I would recommend, if you can, is actually try to mount it off the back of the vehicle, pointing down, and try to get as wide of a coverage of the track as possible. Essentially, you want to think of it like a drone, right? If this were a drone, how would a drone be filming? Generally, it's pointing straight down at the ground, maybe at a slight angle. That's going to give you a very kind of consistent flat surface. One of the drawbacks of filming out the side of the car like this is that you end up with, parts of the road that are closer to the camera have more detail, they take up more of the frame, and parts of the road further away have less detail, they take up less of the frame. So it can result in some issues later on down the line. I figured out some ways to work around that, but if you're getting started, I would suggest try to avoid that altogether. Either mount a camera to the top of the car pointing down, or honestly, if you can, you can just go around, you can walk, you can snap pictures. The important thing is you want to get a lot of overlap. So if you're going to be driving, you're capturing 5 frames per second, you want to be driving very, very, very slowly. So less than 5 miles an hour if possible. And that's kind of what I've found, is that the frames per second that I'm recording needs to be roughly equal to the miles per hour that I'm driving. So if I'm on a road with a 30 mile an hour speed limit, best thing I can do is record at 30 frames per second. I did a road that was 55 miles an hour. I was recording 50 frames per second. So if you're capturing 5 frames per second, go about 5 miles an hour. I think that's a pretty good rule of thumb here. And then to answer Daniel's comment, imagine we have a community of people doing this around the world and connect all the tracks to eventually replicate the entire Earth to drive. You've sort of touched on the long-term goal of mine, which is to build up a community of creators who are able to take this approach and scan local roads, local tracks around them, and sort of, as you say, crowdsource the entire world. Like, get as much into one game as possible and have it all be interconnected, or at the very least be able to work between different zones and things like that. Maybe have an always online connected sim racing environment with tracks and streets and a more social aspect to it. And yeah, just basically allow people to take this process, use it the best way that they can with the equipment that they have, and produce assets that we can all enjoy. I totally agree with that idea, and hopefully we can all make it happen. And that's part of the reason I'm starting to show my process in this video, and I'll start making tutorials, is because I really do want more people to capitalize on what they already have access to. Everyone has a nice camera in their pocket. Everyone in the sim racing community, almost everyone, has a high-end gaming computer with a fast CPU, fast GPU, a sizable amount of RAM. And that's really all you need to get started doing these photogrammetry meshes. It's a lot less labor intensive compared to modeling things by hand. It's a lot less to learn. There are some steps in the process, like you do have to transfer it into Blender or 3ds Max in order to split it up and get it ready for the game engine. And every sim has different requirements for the way that meshes need to be named and textured and things like that. But yeah, in general, this is a much easier way to get into modding versus trying to do stuff by hand. So for your question, Justin, I think 10 laps would be more than enough. Again, it really depends on how much coverage you get in a single frame. So if your phone is positioned and it captures, let's say, a third of the width of the track, then you should maybe do 4 or 5 passes with a lot of overlap between passes, right? You want to have at least 60% of the image overlapping side to side and 90% front to back. So that 90% is going to be you driving forward, and that 60% needs to be between, adjacent passes on the track. So definitely try that out. And, honestly, if you have questions or you're struggling while you're doing that, message me here on Instagram or on Patreon, on my website, contact@realsimroads.com, so I can try to help you while you're going through the process. And the big question, yes, absolutely. So the level of detail for the road surface is insane. Maybe I'll do another live stream or post some photos. There's also on my website, realsimroads.com, there's an article section. And if you look at one of the first 2 articles that I posted, I have some behind the scenes screenshots where you can see the actual mesh without any texturing. And it is every bit as detailed as the real road surface. So not just big cracks and dips. Yes, all of that is captured, but the actual like asphalt structure of the road is captured in the mesh. So literally like this is down to the sub-millimeter scale of detail. And that's why I say that the game engines themselves can't really handle that much detail. You're going to have to create a low poly mesh for the physical road surface and the visual. And then you're going to create normal maps from the high poly mesh. And that's going to give the lighting engine the level of detail that the real road surface has. So again, feel free to message me. I can give more kind of one-on-one instruction for that. And yes, this absolutely can, and that's my intention of doing this, is to replace laser scans, because laser scans are more time consuming, they're more expensive, not just to do the scan, but also to process the assets afterwards. Because the large majority of laser scans do not have any texture data, any color data that's really high enough quality to be used in a game. If a laser scanner is capturing, 360 photos along with it, that's generally good enough for reference. But then they go back and they texture everything by hand, and it's a very time-consuming process. It takes teams of people, weeks, if not months, to do that. So with photogrammetry, you get the textures right away, you get the mesh right away, and then all you have to do is maybe add a little bit of background scenery from Google Maps or whatever source you want to use, add some trees and some street furniture, things like that, and it's a much faster process than laser scans or doing it by hand. And yeah, I'm really, really excited to get these into Unreal Engine. Yes, it is absolutely more accurate. It is easier. Now, accuracy is an interesting thing. Photogrammetry itself is not referenced, meaning it doesn't know where it is in 3D space, on the Earth, etc. The way to create that information is by either using photos that have the GPS data built into them, which is why I recommend using an app like Skyflow and making sure that the GPS is baked into every photo, because that's going to give your track the proper scale. It's going to position it on the map in 3D space correctly. So even when you get it into a game engine, the sun is moving in the right direction, casting shadows in the right direction. So all of that's important. But if you end up somehow not capturing the GPS data along with the images, you'll need to add ground control points. And those are, you either collect them in the field using a precise GPS device or a specialized phone app, or you can actually, I use the software Metashape. You can click on the Google Earth map in Metashape to create those ground control points and then match them up to those same points in your photos. So for instance, in this parking lot, I would find a very clearly defined point that's visible from the satellite imagery, like the arrows pointing in and out of the driveway, or the corners of the concrete where it meets the asphalt in the parking spaces. And that's where I would put my ground control points. And I think what I'll do is I'll do a follow-up to this video when I'm actually processing the data and show that in more detail. But that's really important, because without any sort of geo-referencing data, it can't be as accurate, because it just doesn't know specifically like, okay, this is here, this is there. The software can do a lot with just the camera data, so knowing like the size of an individual pixel, knowing the focal length of the lens and that sort of thing. But to get true to life accuracy, you need some sort of ground control point. And again, you can either collect those in the field, which is the proper way to do it, but a little more time consuming, or, and I believe this is more than good enough for driving simulators, you can create those ground control points from like a Google Maps source or that sort of thing. Yeah, so you can also put your own 3D models to make a full environment. Exactly, yeah. So that's what I'm scanning right now, is just sort of like a base map, and then you can add additional stuff in the background. You can add trees and foliage. Something that's important to note about photogrammetry is that if something is moving, it's going to cause problems. So trees and bushes, even in a slight breeze, they tend to move a lot. And in general, trees just have so much going on that unless you were to do a close-up scan on a tree specifically, it's going to turn into a blobby mess. So typically I remove things like that, and then I replace them with high quality 3D trees or 2D trees in the case of aceto. And again, that is just because photogrammetry is really well suited for hard surfaces, solid objects that don't move, and trees and foliage and that sort of thing just don't really get reconstructed cleanly is the issue. But you will have kind of a reference point of like, oh, there was a tree here, now I delete it. Okay, now there's a hole here. Well, this is where I'm going to put my high quality 3D tree. And again, depending on the racetrack, if you're scanning an actual track, there's probably not going to be a lot of trees in the track area. So you don't have to worry so much about that. You can just kind of scan the track itself and the infield and the pits and things like that, and then add additional stuff later. Even the pits and the buildings around it, you can create your own from reference data, or you can try to scan them and include them in the overall scan. That's really up to you. And definitely, if you try this out, I'd love to hear how it goes for you. So, tweet me or at me or tag me or send me a message. Let me know how it turns out for you. I'd love to drive on your track, maybe feature it on here. And yeah, so I'm going to do another pass with the camera actually zoomed in tighter. And how's the size of the track itself in aceto? So if we're talking about gigabytes and that sort of thing, there's a difference between the mesh size and the texture size. So the mesh itself ends up being, a couple hundred megabytes. It's not anything too extreme. And that is wholly dependent on how many polygons are in your mesh. So if you reduce it to what I would call a game-ready asset, the mesh is not going to be very big. The textures, on the other hand, is where it gets to be intense. So with the texture, let me back up a bit. So if you're doing a 3D model by hand and you're texturing by hand, the traditional way is to use a tileable texture that just repeats itself over and over and over again. So you might have, one or just a couple of 4K tiles that are then used for your entire road. Photogrammetry is a little bit different because the textures come from the real world, so nothing repeats itself. So you end up with a lot more textures to cover a road or a track than you would if you were doing it by hand. So that inherently takes up more data. So Alpine Meadows, for instance, I originally did 8K textures for everything, but the textures were over 11 gigabytes. And that directly corresponds to how much VRAM your graphics card has. So for anyone who has a card with 8 gigs of VRAM, that was causing significant issues where it would pause and stutter when some textures were being unloaded from VRAM and new textures were being loaded in. So what I had to do to compensate for that is I just reduced all of my textures to 4K instead of 8K. The visual quality is still good enough. I don't really have any problem with the 4K textures, but it is kind of a limitation. And again, that's why I'm excited for things like Unreal Engine 5, which can handle both high poly meshes and higher resolution textures. And by that same token, if you have a full resolution mesh, you don't need normal maps. You don't need displacement maps. You don't need ambient occlusion maps, because all those do is they're simulating the way the light would behave if the mesh itself had all of the details. So, this is kind of getting a little ahead of ourselves into the future of sim racing. But somebody just decided to come and get in my way. How is the height determined in the mountains? I know you were able to scan textures, but how are you able to change the angles? So I assume what you're meaning is like, how is the road itself able to map to the correct elevation changes? And part of that is because the photogrammetry process itself is very, very, very good at reconstructing the actual geometry from the capture. So not just the small surface details, but the overall large elevation change in the road itself is sort of estimated and reconstructed by the photogrammetry process. But without those ground control points, without that GPS data telling the software, hey, this part of the map is at 1,000 feet. Hey, this part of the map is at 3,000 feet. Without that data, there's no real way for the road to be oriented properly. So you have to have some sort of GPS input whether it's in the photos themselves or in the ground control points. But that's definitely necessary to get accurate dimensions across the entire road surface. So keep that in mind. If you're going to be doing your own maps, you definitely need to record some sort of GPS data, again, either in the photos themselves or using ground control points. And I'll add really quickly, you also, in general, even if you have the GPS data in the photos themselves, it's a really good idea to add the ground control points, just a handful at the very minimum, to the reconstructed map, just to make sure that everything is exactly pinpointed. Now, I'll add a caveat to that, because some parts of the Google Earth data are not super accurate. Like the one that I scanned recently that I'm working on reconstructing is from Malibu, and on Google Maps, the road goes like this. It up and down and up and down. It doesn't match the real world at all. So in a situation like that, I tend to use fewer control points from the map and just add a couple, like at the top, at the bottom, in the middle, and then just let the software reconstruction handle the rest. Again, this is, I'm a one-man band. I'm doing this myself. I don't really have the time or the resources to go out with like an RTK GPS device and map individual points every mile and do all of that. So my process so far has been to do the best I can with what I've got. That said, if I were to go back and redo it, what I would probably do is, instead of recording the video like I did, I would actually just record JPEGs at 30 frames per second, because each one of those has the GPS data built into it. And that would help speed up the reconstruction. That would help eliminate the need for so many ground control points. And, I'm still learning as I go. Part of what I'm doing right now is I'm about to do a second pass with my camera zoomed in to 35 millimeters instead of zoomed out at 16, just to see, how well can I combine two different focal lengths. They say don't do that. They say use one focal length for your entire scan. I tend to agree with that, but let me see what happens if I try to push the boundaries to get more details on the brick wall and things like that. So without further ado, I'm going to do my next scan here, and feel free to keep dropping questions. I think it's just you and me, Daniel, but I appreciate your enthusiasm. And I'm happy to, even take this offline, maybe do a Zoom call with you if you're interested in learning more about this, because I'm really passionate about it, and I really just want to get the word out. I want the community to know what's possible with equipment that they already have. And it's much easier to learn this, in my opinion, than it is to learn modeling by hand. So yeah, let me do another lap here. And to see how this goes. I might even go out onto the street a little bit and try to scan some of the stuff across from here. Because what I noticed with photo maps is that you also want to have a good background. You want to have some stuff off in the distance that'll look nice, even if it's just out of focus or what have you. It just gives you more options for how to frame your shots and that sort of thing. And what's interesting is that if you've driven Alpine Meadows, which I know you have, Daniel, those traffic cones at the beginning of the map, I scanned from this collection of cones right here behind me. Yeah, this was, I noticed one day that they had some pretty beat up cones that would probably be good for photogrammetry. I just grabbed a couple, and that's another, huge benefit to doing this type of process, is that you're able to grab objects from real life, rocks and street furniture like barricades and cones and all sorts of things, and actually reconstruct them for your maps. So you can add more detail, you can add more realism just by having all these little objects that appear true to life. Oh, it's great that you do cinematography too. Yeah, I really liked your videos. I could tell you had an eye for it. So, yeah, that's kind of how I got into all of this, is by being a cinematographer, having some, camera knowledge and equipment, doing things my own way based on my own experience. And, more or less just like trying to find a better way of doing mods, because laser scanning is very expensive, very time consuming. It's definitely reserved for the developers and serious racing teams that need to recreate tracks. But photogrammetry makes this whole process more accessible, while also making it more just better quality, in my opinion. I think there's a lot more that can be done in this field, and I'm really excited to be pushing the boundaries on what's possible. And if you have any ideas or suggestions, or any roads in Southern California that you'd like me to map, let me know. It's easy enough for me to go out and scan something when the weather is good. That's actually why I just sort of hopped in the car and ran down to FedEx, because I had been wanting to scan this for a little while, and I noticed that the weather was cooperating. But the reconstruction is what's time consuming. So I more or less end up in a situation where I try to collect data as much as possible, and then later on I'll get around to reconstructing it. I'm actually kind of looking forward to May and June here in Los Angeles. We have what we call May gray and June gloom, where basically it's just kind of crappy and gray all day long. But at the same time, that's the exact kind of weather that I want for this type of scanning. So we'll see how much I can get scanned in that time. And what's good is that it's still clicking away, which means I haven't even used 2,600 images yet, or whatever it was. So I'm gonna maybe flip around, try to get this building with this close-up lens, and maybe get this grass one more time and call it a day. I think this one will look really nice once it's all filled out. I'll try to make a lot of pits so you can load it up with other cars and have the whole parking lot full. I think that'll be kind of cool. Just gotta make sure not to hit anything. And yeah, so we're getting the full building here in a good amount of detail, going nice and slow. Gonna try to go along the side one more time, because I know those trees are gonna be blocking a little bit of the front. So I'll try to get an oblique angle here just to fill in those gaps. And if I'm feeling really saucy, I'll probably get out and take some pictures of that patio or that walkway up close. Again, just to have some more detail that gets reconstructed in the background. So I'm gonna go over here and try to do, actually, you know what? I'm gonna tilt the camera down for this last part. I got 261 pictures left. So let's just try to get the grass and maybe some of the road out front, and we'll call it. Oh, hi, Stefan. Nice to have you join us. Just to recap, I'm just demonstrating my photogrammetry scanning process that I use for creating real sim roads. And today we're out scanning the FedEx parking lot near me, and this is going to become a photo map. And I guess I'm going to challenge myself now and see just how quickly I can get this released, right? Can I actually go from just a raw scan to a finished photo map in less than 24 hours? Because that would be a pretty awesome achievement in my book. Oh, all right. So the camera just ran out of photos, and I'm going to do something weird and drive over the sidewalk here. And I'm going to double check and see if I feel like I need anything else before I leave this place. And yeah, if you have any final questions for me, or if you want to offer any suggestions, I am totally open to it. So I'm just going to stop and get out and check my camera. All right, well, the sun is coming out. It's starting to cast shadows, which are going to cause a problem for me. So I'm going to call it here. I'm sure I got more than enough to produce a pretty awesome photo map. So I'm going to end this live stream. Thank you for tuning in. Thank you for being here for the whole thing, Daniel. I appreciate it. And yeah, I'll get this out as soon as possible and let you know how it goes. All right, peace. How do I end this damn thing?